Hello, this is an IB question, but it's a question that many of the IB questions, they follow the same pattern. So let's see them, because this is a whole clusters of exercises which have more or less the same way of solving them. Let's see the problem. It says let L be the tangent to the curve, this curve, at the point 1 point E square. Find the coordinates of the point where L meets the x-axis. Let's see first the problem in a context. Let's graph it here to understand what we have to deal with. So the function is x times e to the power of 2x. Let's see it, graph it. Let me change a little bit my minus 10 to see it better. Graph it. Let's put also some values in y minimum, minus 5, and let's graph it up. Minus 10, yes, minus 5. Okay, so you see here, let me zoom. Let me zoom more here. Zoom in. So you see at some point here, no, basically I don't need to zoom. I will zoom out to see it better. Now you see the function, and I have a tangent at the point x equals 1 e square, 1 and e square somewhere here. So let me graph it here to understand how you will solve this kind of problems. So basically the function goes like this, it goes a little bit down and then goes up. Now so my graph, the graph of this function is this one, sorry. Now find the coordinates of the point where L meets the x-axis. So I have a line L which is at the point 1 e square. Let's say that this point is here. So I have a tangent, there is a tangent, and I want to find where this tangent meets my x-axis. So basically I'm searching for that point here where the line meets the x-axis. How should I find it? The first thing that you have to do is that you have to find the line, obviously. Now this line is tangent to this curve. So since it's a tangent, I can find the gradient of this line. How? If I will take the derivative of this function. So if I'll take the derivative of y, is going to be what? The derivative of x e to the power of ex, which is the derivative of the first. Now this is product rule and chain rule, as you will see. The derivative of the first, which is 1 times the second, plus the first times the derivative of the second. So basically it is e2x plus, now the derivative of that is the derivative of e to the power of x, my function, which is the same, times the derivative of 2x. So here I have a quotient rule, a product rule, and a chain rule at the same time. So the derivative of 2x is 2. So the answer is 2x e to the power of 2x. Now this is the gradient of the line. Okay, this is the gradient, but I can find exactly how much is it because I have the point. At x equals 1, how much is the gradient? So when is 1, the gradient of the line L is e to the power of 2 plus 2 e to the power of 2, which is 3 e to the power of 2. So this is a number. So basically I found the gradient of the line. So the line here, the line is going to be y equals mx plus c. So y equals, how much is m? 3e to the power of 2 times x plus c. Now to find this point here, to find c, I have to substitute one of my the points that I have, so as to find the value of c, because the line passes from one point e square. So to find c, I will just substitute x equals 1 and y equals e square equals 3 times e square times 1 plus c. So c is going to be e square minus 3 e squares. So c is minus 2e square. So now I will come back, and since I found my c, I can put it here. So my line is y equals 3e square times x plus, not plus, plus c, which is minus 2e to the power of 2. So now I have my line. Now I want to find what the question says, the coordinates of the point where L meets the x-axis. So I want to find for this line here, this line, I want to see where it meets the x-axis. Where it meets the x-axis is where the y is 0, because it's a point, all the lines, to find the intersection with x-axis, my y is 0. So in my function I will put where y is 0. So 0 is equal 3e square x minus 2e square. So minus, sorry, 2e square is equal 3e square x. So from here I will have that x is 2 over 3. So obviously the point of intersection is where the line meets the x-axis is 2 over 3, 0. Very interesting exercise. What you have to do most of the times is, if you will graph, if it's a paper with a calculator, if you will graph it, you can easily find these points of intersection, what is the gradient. If you don't have the calculator, if you have a rough idea how the line will look like, because this is an exponential, so it will look like something like that, you still can draw it and make a sketch of the graph.